Hello, in this video we will discuss exponential functions. And exponential functions are generally going to have this look, this f of x equals a to the x. A is the base, okay, and A must meet some conditions. It's just a number, by the way, but it must be greater than 0 and it cannot equal 1, all right? So you can see some examples down here where you have a base of 2, that will be your A. Here you have a base of 3. Here you have a base of 10, okay? So your A value just has to be greater than 0 and not equal to 1, all right? So another thing that you're going to notice about exponential functions is that your variable is in that exponent position, okay? So whenever you see a variable in the exponent position, you know that you're dealing with an exponential function, and you can see that in each of these examples down here, okay? So exponential functions, they can be what we consider to be exponential growth or exponential decay. So let's talk a little bit about that here. So this graph on the left, all right, this would be considered exponential growth, okay? And in this case, your base is going to be greater than 1. So your base could be a 2, so we could have like f of x equals 2 to the x, or your base could be maybe a 4, okay? Just anything that's greater than 1, okay? And what happens is as our x values increase, so as our x values increase, our output values are also increasing, okay? So you can see what's happening here is as I move towards the right, I'm going up, up, up very quickly, okay? And so exponential functions tend to grow very quickly, all right? So that is a growth, exponential growth. Now, if you'll look on this graph here on the right, this would be considered exponential decay, all right? And you can see here that your A value must be between 0 and 1. So your A value could be maybe like a 1/2, okay, or maybe it's like a 1/4, okay, that kind of thing. So it's, remember, your A cannot equal 0, but in this case, as long as it's something in between 0 and 1, then it would meet this condition. And as we're moving towards the right, our output values are decreasing, okay? So you can kind of see how on the graph, as I move towards the right, okay, my output values are getting smaller, 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 okay? So let's talk about domain and range. So each of these exponential functions have a horizontal asymptote. And so we've talked about horizontal asymptotes before, and so this is something that you're familiar with, and that would be a horizontal asymptote of y equals 0, okay? And similarly, this guy over here would have the same, okay? It would have a horizontal asymptote of y equals 0. So exponential functions are going to come in really close to that horizontal asymptote, but not actually touch it or cross it. So you can see here on this left side how it's going, that it's sort of going to level off, okay? So it's going to kind of come in really, really close to that horizontal asymptote, very, very close there on the left. And then similarly on this graph on the right, you can see how the graph is going to come into that horizontal asymptote on the right, okay? So that kind of helps us to determine what we would use for domain and range. So for each of these graphs, okay, my domain is going to be negative infinity to positive infinity, okay? So because both of these are using all of the x values from left to right. Now, on each of these, they also have a range of 0 to infinity, okay, range of 0 to infinity, because if you'll notice that they're not actually going to touch this asymptote here, okay, but I'm using all of those y values up, okay. Similarly on this graph here, it's not going to touch that asymptote, but it's going to use all those y values going up in that positive direction, okay. So notice the parenthesis, okay, you do need a parenthesis on that 0 because of that horizontal asymptote, okay. So let's keep looking at some other examples here. So you can see where they have graphed two different exponential functions. This first one here is the 3 to the x, and that is the one that is red here on the image. And the second one, they have graphed the 1/3 to the x, and that is the one that is the blue color, okay? So one thing I wanted to show you was that when you are calculating with exponential functions, you do need to be a little careful thinking about your exponents. So like for this right here, when they were using an x value of -3, all right, and you're plugging into that 3 to the x, okay? So f of -3 would be 3 to the -3, and then because of exponent rules, and that's negative, we would move that to the bottom, and that would make that a +3. And then 3 to the third is 27. And so that is how they're getting that 1/27 there. All right, similarly, like if you had f of -2, that is going to be 3 to the -2, which is 1/3 to the +2, which will be 1/9. Okay. All right. Now, if you look at, let's get some of this out of the way here. We'll look at some of the other ones. If we look at the other function, okay, the g to the x function, and we are looking at, say, let's look at the 2, okay? So the g of x function is 1/3 to the x, okay? And then g of 2 would be 1/3 squared, which will be 1/9, okay? And that's where they're getting that from, okay? And then if you have, let's say, a negative number, so like g of, let's say, -3, okay, that would be 1/3 to the -3, okay? Now, when you have a negative on the outside of a whole fraction like that, what you can do is flip that fraction, and that will make that exponent positive. All right, so you notice I'm using the reciprocal of the 1/3, and then that's just 3 to the third, which is going to be 27. Okay, and so that's how they get that. So you have to be a little careful when you're plugging in negative numbers because your variable is the exponent, and you have to remember to follow your exponent rules when you are evaluating for a negative exponent. So anyways, kind of back to what we were talking about before. Notice here this f of x, okay, this f of x graph is a growth. As the x values increase, my y values are also increasing. But then notice g of x, all right, g of x is a decay. So as my x values increase, my output values decrease, okay? So just like think about the different types of growth and decay as you're working through problems. You also always want to consider like domain and range and make sure you're using the proper a values, right? You're following the rules with the type of base that you have to have. And we will learn more in another video. So I'll see you in the next video.